Um, so a quick recap of what we have seen yesterday. Yesterday we covered our journal program, which was mouse event using adapter. Now the second journal program statement is like this: write a Java program to implement keyboard events. But in this statement, they have not mentioned whether to use adapter classes. So we just thought of having both the ways in our journal program. I mean, both the techniques using listeners as well as using adapter classes. So this program of keyboard events, we have implemented key listener here instead of using adapter. So this is our old method, and also because they have told us keyboard events, and as you all know that key event class has only three methods. So there is no problem in overriding all the three methods. Not like mouse events, we had 7 methods there, and the program would simply grow in size. So here, since we have only three methods and they have not mentioned which events to implement and also whether to use adapter classes, so we thought of using all the events and also using the listener. So here my class name is journal2, which is extending applet. That means my interface is of applet, and we are implementing key listener. Here we can use multiple inheritance because we are using interface here. When key listener is an interface, one class and one interface or two interfaces, this thing is allowed. Then here, we have already seen this program, but just revision. We have one string variable which is initialized to null. Then we have x and y variables which are initialized to 10 and 20 value, integer variable. Then in the init, because we are going to respond to the key events, I am registering with the keyboard listener, that is key listener. And
Excuse
the
me,
app,
ma'am.
yes.
Ma'am, I'm not able to see in the screen.
Okay, what about others?
It is visible, ma'am.
Okay. I'll just reshare. You just see who is this who didn't, I mean, who has problem with visibility.
Ma'am, Indrani, ma'am.
Yeah, just I will share it once again. You just check.
Okay, ma'am.
Is it visible now?
No, ma'am, still it's not visible.
Okay. I will use the another technique, but then there will be a problem when I will execute a program. Anyways. Um, is it visible now?
No, ma'am. Ma'am, can I
Ma'am, it's
rejoin
not
them?
the problem on your end. I guess when we close the application and rejoin again, the screen disappears. It's not the problem on your end.
Okay, okay. Fine. I
Ma'am, she
thought
has
there.
to rejoin.
Okay. Uh, yeah, Indrayani, right? You just rejoin
Yes.
and try. Okay,
Okay,
we'll
okay,
continue.
ma'am.
Okay, so here we have init method wherein we are registering with the listener, and since applet body itself is going to respond, so here directly we have called add key listener. Then we have we ha we are going to use all the three events. So we have three methods here: key pressed, um, and key up. Upon key pressed, what we are going to do here, we are going to show a message on the status bar: key is down. And when the key is released, we are going to display a message on the status bar that key is up. And when key is typed, what we are going to do is we are going to display whatever characters are getting pressed by the key. So how do we get that character which is pressed by the key? Using a method called as getKeyChar. And remember, these get key, char, get x, get y, all these methods, they belong to the event classes. So this method has to be used with the reference of the event class. So key event E, we have created a reference as E. So E dot get key char. This will give us the character which is pressed. And as you all know that the next character will override the previous characters. Since we want to concatenate even the previously typed characters, that's why we have to use this expression here. Message equal to message plus E dot get key char. So this will give us the entire typed message of all the keystrokes. And then we are calling repaint here. See, whenever we write on the message body, we use repaint. So repaint will in turn call a paint method. So what are we going to do in paint? We are going to use drawstring method. That means we are going to write on the applet body. What are we going to write on the applet body? The message, whichever is formed by the keystrokes, and on the x and y coordinates, which we have initialized initially here with the value 10 and 20. So this is a simple journal program using key listeners and applet. Yes, any doubt in this? Is it clear? So we have covered two journal programs. What you people can do, the modifications. This journal program wherein we are not using adapter classes, you people try to change it using adapter class, adapter plus inner, and the other class, the previous program, you try to change it using listener. Of course, changing it using listener is not difficult because it is already available in our journal, in our textbook. So this program which we have done using the listener key events, that you have to convert to adapter. Try doing that. And when you use adapter, you can skip other event, just use mouse, any one of the methods, like use only key typed. Don't use key pressed and key release. So this is the modification you people will try. Fine. Okay. Now let's go ahead with the next theory concept, which is the last part in this chapter. Then we will be starting with swing programs. Fine. Okay. What is the next concept here? Do you see the screen?
Yes, ma'am.
Yeah.
Anonymous inner class.
Anonymous. What do you mean by anonymous?
Unknown.
Yeah, unknown or without name. Fine. So we have already learnt inner class yesterday. Inner class is the class which is defined in the body of any other class. Fine. So that is called as inner class, and the qualities of inner classes are: inner class can access all the members of the outer class. So that becomes advantageous to us when we use event handling and when we use adapter classes. So here this anonymous inner class may make it again simpler, but this concept has to be, it's little tricky. People have to understand it, and that's why, because it is little tricky and students may have confusion, or when they use this technique, then they may have, they may invite some difficult viva questions from the examiner, because if you implement difficult concept, then the examiner will ask you the questions based on that concept, isn't it? So to avoid that, in our journal program, we have not used anonymous inner class. We have used only the inner class. But this anonymous inner class will make our program again smaller. So let us see what is this anonymous inner class. So as per the definition, anonymous inner class is the one that is not assigned a name, which doesn't have a name. Its definition directly starts with flower bracket. That means without a name, it directly starts with flower bracket. You may be surprised to know what kind of class will it look like. I mean, but okay, let us see the next point, which is important in connection with this anonymous inner class. It is usually used with interfaces or abstract classes. It is usually used with interfaces or abstract classes at the time of instantiation. What do you mean by instantiation of a class?
Creating objects.
Creating objects. Do you see any contradiction in this sentence?
Abstract
What is
classes cannot have objects.
Yes, and then we are talking about instantiation here. Same thing is with interfaces, isn't it? They cannot have objects, but then what is this instantiation we are talking about? That's what is the technique what we are going to see here. It acts similar to any other class that implements an interface or extends the abstract class. It contains the code to override the abstract methods. Fine. So what does this class do? Anonymous inner class is similar to any other class that implements an interface or extends the abstract class. Fine. What Suppose now whenever we want to use interface or abstract classes, what do we do? How do we use interfaces in the program? If we have to use interface, how do we use? We create another class which implements the interface, and then whatever abstract methods are defined within the interfaces, those will be overridden in our class. And then we create object of that class, child class, and then we execute those methods. This is how we make use of the interfaces, isn't it? So that means uh, whenever we have interfaces or abstract classes, we cannot use the methods as it is. We will need another classes. Those classes should either implement the interface or extend the abstract class. When it comes to class, we know that we have to extend them. When it comes to interfaces, we need to implement them. So we should have a child class which either implements or extends the abstract classes, and then that class should override the methods, abstract methods which are provided in this interface or abstract classes. And then we create the object of that class, and then we will be able to call the methods. We will be able to override the methods and then call those methods. So here, the class which actually implements the interface, what is the job of that class? It's just going to implement that. It is going to extend that, or it is going to override, provide the body for the uh, abstract methods, which will not have body. So these classes, people thought of, I mean, Java developers later on when they thought that the name of this class is not very important. So these classes which actually implement the interfaces or extend the abstract classes can be made anonymous. How they can be made anonymous? Let us see the technique. To make you understand, I have created simple programs here, because I thought if I directly explain you that big journal program, you may have confusion. So here is where I have created a small interface. What is the name of the interface you see here? The program which I have highlighted. What's the name of the interface here, which I have
A2.
highlighted?
A2.
A2. What does that interface have?
F1 method.
Which is, what type of method it is?
Void.
Void is fine, but
Abstract.
abstract method,
Abstract.
because interfaces will have abstract method. Now, as you all know, when we use these interfaces, we use like this. Okay. Uh, normally. Okay, let me write this program here. I'll say public class child What will be the output of this program?
Hello.
Hello. So what we have done here, we have created a child class which implements A2 and then we have overridden F1, and then in the main method I have created object of the child class which is allowed, and then I call the method F1. Okay, so this is the usual way how we make use of our uh, interfaces or whatever abstract methods we have defined. So now here there is one more program. What are we trying to do here? In this I'm using a class used to, and in this I have a main method. Remember that all these programs are there in the same package. You know that in the same package we can access classes content of each other, public contents, fine, or which are not non-private contents we can access. So this here we have interface A2 wherein we have abstract method F1. Here in this program I have created a class used to, and in this I have created a main method, and I am trying to instantiate the class interface A2. What will happen here when I try to do this? What will happen usually when I try to, what am I trying to instantiate here? What is this A2? What is this A2 I'm trying to instantiate?
Interface.
Interface. So is it allowed to instantiate the interface?
No, ma'am.
No. So the program when I execute, it will give an error. Exception in thread main, uncompilable source code. A is abstract. A means that particular class is abstract, cannot be, here A means A2 actually. Yeah. Cannot be instantiated in the program use2 dot main. So here use2 is the class name. In the main method, it says A2 is abstract and cannot be instantiated. So this is the error we get because we cannot normally instantiate the interfaces, isn't it? But there is a way by which I can instantiate interfaces with the help of anonymous inner class. You know that A2 actually gets instantiated indirectly here. How? I am creating a child of A2 and then I am instantiating that child class with the name obj. So obj, when it calls f1, it actually it goes to the I mean this particular f1 which is defined in A2 will be used only by this child class indirectly. So indirectly we are using A2, not directly. But here the same thing can be done here directly. I can try to initialize. How? So this is the method. All of you concentrate on this program 3. Is the screen visible? Program 3. What is the class name we are using here?
New used to.
New used to. In this I have a main method and I am trying to instantiate. Can you see here I am trying to instantiate A2. I am creating obj. A2 is again an interface. Fine. So the same interface I am trying to instantiate. Here it will allow it. But what is the syntax I am using here? See, normally what we do, we give semicolon here, right? Where the cursor is blinking. Yes, can you see here new A2?
Yes,
One,
ma'am.
yeah, here
Yes,
we
ma'am.
normally used to give semicolon. Fine. But here the anonymous inner class definition goes like this. It is used in the instantiation of abstract classes or interfaces. So here we are trying to instantiate A2, that is the interface, and instead of ending the instantiation here directly, see when I'll close the instantiation with the semicolon. So before I give semicolon here, what I have started here?
Flat bracket.
Yeah, I have opened a flower bracket. So that flower bracket indicates some block, or actually it is the class, anonymous class, which doesn't have a name, but I have started writing its body with the flower bracket. So this is the way anonymous classes are defined at the time of instantiating either abstract class or interfaces. So the body of the anonymous class begins here, and anonymous classes are actually used to override the abstract methods which are defined in the interface or the abstract classes. So I am overriding here F1 by writing some message. I am from anonymous class. So after I close the method body, I am closing the class body. See, class body begins with the flower bracket here and I am closing it here, and then I close the semicolon. I give a semicolon. This semicolon actually belongs to this location. Okay, let me use this shape and see. Yeah, these two have come to two different pages. So anyway, I'll just shift it down. Now can you see the semicolon which was supposed to be given here after the object creation? That semicolon we are giving it here. In between, what do we have here? This is the anonymous class body. And then once I have done that overridden F1 by using anonymous inner classes, then this particular object which we have created, this object belongs to the interface actually, which is not allowed. But because of this brackets here, because of this class body, definition of a class, Java compiler will assume that there exists a class which is similar to a class. The meaning will be like this. There exists a class which is similar to a class which has implemented the interface A2 and overridden the abstract method F1. So this class here, fine, let me just see, this class here is yes. Did you understand? So, when we try to instantiate the interface or the abstract class, remember that we have to concentrate on whether that instantiation is followed with the brackets, flower brackets. If it follows with the flower bracket, that means there exists a class which is as good as the class. The meaning is here that this anonymous class implements this interface or extends this abstract class, and it overrides the abstract method here, and hence such instantiation will be allowed by the Java compiler. And then that object which is created will use this overridden method to call, and then the program will execute successfully. I can show you that execution here. Can you all see this here? So here in the same package I have interface A2 defined. See here, left side in the VK event handling only I have A2.java, that is the interface defined. And then the same A2 I have tried to use here in the another class called as new use2. So in this new use2, directly in the main I have tried to instantiate A2, which is normally not allowed. See, we tried to instantiate that here in case of use2. We tried to instantiate, but then we got the error message here. I showed you the error message also. See, I'm rerunning. There is some other program which is getting executed here. Anyway, so this program, if you try to execute, it will give error, fine, saying that A2 cannot be instantiated. But now when I'm using it here along with the inner classes, anonymous inner class, anonymous class, then it will get executed. It's executing some other program. Let me check it later. But this program, when we execute, we will get a message, I am from anonymous inner class. So have you understood this anonymous class here? So what are anonymous classes? Let us sum up once again. Anonymous classes are those which do not have name. They are normally defined. Their definition directly start with flower bracket and closes with flower bracket. These anonymous classes are usually used with interfaces or abstract classes at the time of their instantiation. Normally abstract classes and interfaces are not allowed. Their instantiation is not allowed. But here with the use of anonymous classes, that instantiation is allowed. So how it is allowed? See, the syntax goes like this. We normally try to instantiate, but before we give semicolon here, we start with the bracket indicating that it is a class body. And normally what is the use of anonymous classes? Anonymous classes, they override the abstract methods which are defined in interfaces. So here this anonymous class overrides and then the class body is closed and then the semicolon is given. Now this completes the instantiation of that abstract class or interface, and now this object which is created through this instantiation can call the method which is overridden in the anonymous class body, and then the program can be executed without any interruption or error. Is this clear to you? Okay, the same
Yes.
concept when it is implemented in our program. Now, which was our program? Our program was using mouse listener. Fine. So here we have the class name as anonymous inner class demo. Fine. Which is extending applet. So as you all know, inner class we had used to create to use adapters. Fine. So earlier program, let me show you once quickly, which was the earlier program which where we had used inner class using the adapter. See, our program was like this. We had one class which extends applets. We require two classes, right? One to extend applet and second to extend the mouse adapter. So inner class demo is going to use applet and my mouse adapter class, it is going to use adapter. So this my mouse adapter is actually the inner class. Its job is to just use the adapter. Fine. So here now the same my mouse adapter, now we are going to make it anonymous. How we can make it anonymous, let us see in this program. See, this is the outer class, anonymous inner class demo, which is going to use applet. Then inside in it, I have tried to register. Now, when I register here, I try to use that class, the child class name here, which is going to extend the mouse adapter, isn't it? Please remember this line. Fine. Add mouse listener. Remember this line. I will take you to the above program again. Okay, let me try to split here. Okay, so the above program, we can just compare both the program. That's why I've tried to split the window so that we can see both the parts in the Word file. So here this above program uses the child class which is named, which is not anonymous. It is a class which has a name. Fine. So here this inner class demo is outer class, and inside that we have, okay, we have used this class my mouse adapter. Now remember the outer class, when it gets registered with the listener, add mouse listener, it has to use the reference of that child class which is going to extend the adapter. See here, my mouse adapter. What is this? It is a child class, myMouseAdapter, which has inherited or extended the MouseAdapter class. It's a child class name here we use, isn't it? So why do we use child class here? The child class is just used to reach the mouse adapter. Actually, we want to use mouse adapter, but since we can't directly go to mouse adapter as it is the interface, we can't create its body. That's why we create a child class here. And through the child class, we are trying to reach that uh, parent class, which is mouse adapter. Fine. So through this child, we are trying to reach this parent class. So avoiding this step here, skipping these many lines. So can you see here? I'm trying to skip these lines, and instead of this, I will directly try to reach that mouse adapter. So how I can do that? So here I have done that in the program. Down you see, in the init method, add mouse listener is there. So in this, instead of using the child class name new my mouse adapter, what I have used here directly? I have used mouse adapter class. Directly I have used new mouse adapter. So instead of using a child class which is going to extend from that particular parent, I have directly contacted the parent. And here, this directly contacting the parent and creating its child is actually not allowed. So we are going to make use of anonymous class here. Anonymous class. So can you see here anonymous class definition? Instead of giving a semicolon here, directly I have started with the bracket. So, and then we have tried to override this mouse pressed here. And then that overridden method, I can call it here. Please note that this outer bracket is also closed after this here. After the bracket, so that instance anonymous inner class immediately follows the instantiation line here. Fine. So this outer bracket is closed after this, and then uh, we have closed this bracket. So this particular instantiation of this mouse adapter can be done as if we have created a child class which has extended mouse adapter, and then it has overridden this particular method. So instead of that, directly I have tried to override that method using the anonymous inner class, because anyway otherwise that child class name was not so very useful. Without the name also that work can be done. And then with the help of that, directly I in the anonymous inner class here, directly I've overridden mouse pressed, and then show status method is called here, and then the program gets executed. Here I do not require object again. Why? Because we are here, both the qualities we have followed. One is anonymous and second is inner class. Because this anonymous class is a inner class of this applet class. So directly that method can be called even without creating the object. Show status. Why? Because it is an inner class. So anonymous plus inner, both these qualities are there in this class, and that's why directly we can call show status. So our journal program, if we implement anonymous inner class, it becomes so small. We hardly require any lines. Clear? So this was a concept, last part of the chapter. And with this, the chapter ends and next chapter begins with swing program. Clear with this? Any doubt here? One more doubt you may have here. This mouse adapter is not abstract class or interface. Then why are we using anonymous class here? for instantiating mouse adapter. We could directly try instantiating mouse adapter. Why are we using the child classes? Why? Because these mouse adapter, although they have body, what kind of body they have to our methods? What kind of implementations do adapter classes contain?
Empty.
Empty. So empty implementations, are they any useful? Are they of any use? They are not very useful. Only thing, just to showcase, just for avoiding that problem of not having a body, just to show that it is not abstract class, abstract method, it has a body. So for namesake, these mouse adapter classes provide body, but that body is of no use for us because it is empty. So to again we need to override, isn't it? So anonymous classes are used. Let's change our definition little bit to make you understand. Anonymous classes are used at the time of instantiation of the parent class when we want to override their methods directly. So because we want to override the method mouse pressed, which is defined in the mouse adapter class, for that, normally we used to use a child class which used to extend from this, and then we used to override. Instead of that, here we could directly define the class by using flower bracket, and inside the class the job of overriding a method, I am doing it as it is, and then my definition gets closed here. And because yeah, we have overridden here, and then our job of execution also ends here itself, because we are trying to display it on the um, applet body. Here I don't even require an object because I'm combining the advantage of inner class here. So I can just say show status. Now my question to you people, what if this wouldn't be a inner class? What change you would require?
We'll make use
Then
of
you would,
child class.
yeah, either you make use of a child class or anonymous class you can make use of, but you would require to create object as we did in our program. Which was our program? This small. Here we used anonymous class. See this F new use to I created this program to demonstrate you people. Yeah, where was that? Okay, let me show you from this here. I had to create this particular instantiation. Whenever I did that name, I had to use. That's all. Fine. If it wouldn't be inner class. So because it is a inner class, I don't even require this object. I have just created a reference here. See. I have just created a reference called as new, and directly I've used parent class name, and then because it's a inner class, I don't require object to call in this outer class method. I can directly call that method. This is how I could simplify the program. So I've given all the explanation of individual lines in the notes. So I will circulate this notes today, and then I will send you these two journal programs also. So this completes our first chapter. Actually it should have got over in 8 classes, but we have taken almost 15 classes for that. So now we have to go little faster. Clear? So we shall end now.